Hello class, in this video I'll be showing you what it means for a function to have an absolute maximum or an absolute minimum. Let's begin. First, a little definition. We'll let f be a function defined on some interval. We'll let c be a number in the interval. Then f of c is the absolute maximum of f on the interval if f of x is less than or equal to f of c for every x in the interval. And f of c is the absolute minimum of f on the interval if f of x is greater than or equal to f of c for every x in the interval. And so what I'm going to do is I'm going to draw two basic graphs here to show you what's going on. Okay, so I'm going to let this point right here be C, so that the output is f of c. Now notice, no matter which values of x I choose, each one of these outputs is going to be less than f of c. So we're going to call f of c an absolute maximum. I will draw another picture to describe the absolute minimum. Okay, so I'm going to label this point right here. I'm going to label this C. So the output value is f of c. I could pick any random value of x and notice that each random value of x has an output value that's larger than f of c. Therefore, we can call f of c an absolute minimum. Okay, so now that we got absolute maximum and absolute minimum out of the way, we have what's called the extreme value theorem. And the extreme value theorem states a function f that is continuous on a closed interval ab will have both an absolute maximum and an absolute minimum on that interval. And I'm going to draw a couple of pictures to show you what I mean. Okay. We'll call this point A. We'll call this point B. Okay, so we'll call this function f of x. Okay, so right now f of x satisfies both the fact that it's on a closed interval, so f of x is on a closed interval, and then f of x is continuous, which means there are no holes or gaps. This function has an absolute minimum and an absolute maximum. So if we take a look here, A f of a is going to be the absolute minimum. And if I label this point right here, we label this C. F of C is the absolute maximum. Okay, so this function has an absolute minimum and an absolute maximum because the function's on a closed interval and the function's continuous. Now I'm going to draw a function that doesn't meet one of the conditions. Okay. There's A. There's B. That's the function f of x. So again, f of x is on a closed interval. F of x is not continuous. And why is it not continuous? Well, because there's a hole at C. Now, if I want to find the extrema of this function, let me just make that all purple real quick. It looks like f of a is the location of the absolute max. So f of a is the absolute max. But if we take a look, there is no minimum, because where the minimum would be, there's a hole. So there is no absolute minimum. So for a function to have an absolute minimum and an absolute maximum, the function must be continuous on a closed interval. And if it doesn't meet both of those requirements, it is possible that the function will either not have a minimum, not have a maximum, or it may not have both.